I didn't hear a response. I assume. Oh yeah, here they come.
There they come. Hi, everybody. You can open up your videos and your microphones if you want to do that for right now. And then we'll have some introductions. And then we'll have you mute your videos. We'll go through some of the expectations of the session. But if you do not mind right now, go ahead. And if you go to participants and you click on more, then if you would not mind, right beside your name, if you would put a T if you are a teacher, and an S if you are a student. So a T if you are a teacher, and an S if you are a student. And that way, when we do some breakout room sessions, we make sure that we have everything evenly distributed. So just to welcome you today, welcome to our first AP Computer Science A content review session. Welcome, and I am Dr. Sherry McGuffin. I am STEM coordinator for Advance Kentucky. And we are going to be working today with Mel Hoffert, and Mel will introduce himself in just a few minutes, and I will relinquish the microphone and let him have at it. But as you go through the content review session, just a reminder, it's intended for a Kentucky audience, but we, as space permits, which in APCSA, we are glad to see we have a good number today, welcoming students and teachers from other areas. And we're going to do all that we can to provide every student with an equitable opportunity to learn. So during the session, we're going to encourage your participation, but please know that any participant causing a disruption to the session will be removed. And again, here I'm Dr. Sherry McGuffin, STEM coordinator. Here's my email if you have any questions, or for some reason you get disconnected and you need to contact me, anything like that. And then my Twitter handle is at Dr. McGuffin. I'd love for you to follow me. I try to post a lot of good STEM things along the way. So meeting etiquette, microphones, all participants will be muted upon entry. However, so please leave your microphone off unless you're otherwise asked. With a small group, we generally like to have some type of interaction. And so as Mel directs, you could open up your microphones. We'll have some conversation. Video, again, videos are going to be muted upon entry, and you can leave your video off unless otherwise asked. And again, we'll leave that at your discretion as Mel goes along through. And then chat, please use the chat button as often as you choose. I'll be monitoring the chat while Mel is speaking. And so please ask any questions. And if one of us doesn't know the answer, we know where to find it usually. There will be a recording of today's session. So today's session is going to be posted after the event on our content review session page. And you can access that with the same bit.ly link in which you registered. So the links to the handouts, all information for future content review sessions, they can be found at bit.ly at Advance Kentucky. So with that being said, I'm going to stop sharing from here. I'll be monitoring the chat, and I'm going to relinquish the microphone. Mel, you are on. Let's see. I don't see, let me answer a few questions here really quickly.
Sure. Okay.
Rename in the participant window. And David, if you go to, you hover over your name under participants. Now, it may be harder to do this on the phone, but there should be a more. And after you click on more, there's rename. There we go. So again, if you have any other questions in the chat, please feel free to just have at it, and we will get started. Thank you very much.
Good morning, folks. My name is Mel Hoffert. I hope all of you are wearing red, because red is the color of the day. So I hope you did that. Yeah. Okay. Happy Saturday to you. And thank you for being here today, sacrificing your Saturday when you could be out in the sunny, chilly day, right? Doing whatever. So thanks for being here. I've shared via the chat, I've shared a link to our slide deck for today. And that's going to be really important. Two things are going to really help our productivity and our ability to be able to conduct business and go through this review session in an acceptable way for everyone. Number one, for you to be able to have that slide deck and navigate along with me, and also have access to the various links that are in that slide deck. Really important, because my expectation, so here's number two, is that all of you are interested in participating, being active participants in what we're doing today. So my expectation is that you'll chime in, you'll chat, you'll bring up your mic. We're going to do breakout group activities that you'll participate with your peers in those. And by doing so, we'll have a great morning together, and hopefully we'll all learn a few more things about Computer Science A. Okay, I'm going to, hopefully you guys can get to that slide deck link. Go there now and let us know if there's some issues with you accessing that. I'm going to pick up on the share and head on over to, let me go to the right. Here we go. I'm going to go over to the right slide deck. There we go. And there. All right. So you should have access to the slide deck, and the very first slide looks something like this. I'm going to pause for a second and just make sure that each of you have access to that. While you're doing that, let me introduce myself to you. My name is Mel Hoffert, and I'm reporting to you from the basement bunker, my basement bunker in Cincinnati, Ohio. Not far from the Mason-Dixon line. I mean, Cincinnati, it's right on the Ohio River. And I've had many opportunities to visit the state of Kentucky. It's a beautiful state. You guys have an awesome state. You know that, don't you? In fact, I have two of my daughters. I'm going to talk about my children here just briefly, but my two daughters, they live in northern Kentucky. They love the state. Dad, we don't want to cross the river. We don't want to come back to Ohio. We love Kentucky. So there we go. And I've been teaching AP Computer Science in the Cincinnati area for, golly, 20 plus years. Like, holy cow. And prior to that, I was a software engineer. I worked in the software industry for a long time and developed all kinds of apps. Yeah, I'm an old man. Been around the block a few times, and established very early in my teaching, AP Computer Science teaching experience, a relationship with the College Board, with Advanced Kentucky, with NIMSY, with A+ in the state of Alabama, with AP Tippin, all these various College Board kind of groups that tutor students, train teachers in the area of AP Computer Science. And it's been great. Been great to travel the country. Yeah, I was uh, talking with my family just yesterday, and it's been now about 10 or 11 months since I've been on a plane. But prior to that, I was traveling a whole lot, doing tutoring and training teachers. We're doing a lot of that virtual, and it's working out very well. So my expectation for today's session are very high. The technology is serving us very well. You see on the very first slide, a collage of my children. I'm not going to go in a prolonged way on and give you a daddy report about my kids, but I will say this. I have three children, and all of them, even though their passions and interests are varied, I mean, they're very uh, disparate. I mean, they're widespread. Even though their passions are quite different, each of them, here we go, each of them have discovered how they can season their passions with computer science to open up all kinds of interesting possibilities at the college level and for their career. Now, my older daughter, you'll see here in the lower right-hand corner and in other places as well in that collage. She has since graduated from Northern Kentucky University, but she has a degree in bioinformatics. Look for that informatics tag when you are investigating, when you are researching different colleges and universities. Informatics means that you are sprinkling computer science with something else to create all kinds of opportunities for yourself. So she's in the realm of bioinformatics. That's where you combine statistics and you combine, of course, biology and computer science, and you have some really cool stuff. And she works for, she's a project manager for a pharmaceutical testing company. They've been involved with the COVID vaccine and cancer research, a whole variety of things. But what she tells me from her bioinformatics training is that those little critters that we see under the microscope, they operate a lot like computer programs. In fact, she tells me that they talk about solving cancer now instead of curing it. I thought that's very interesting. So there you go, bioinformatics. My son Chandler, he he's in his early 20s and he's a performing artist. He's on this. He likes to be on the stage, actors, a musician. He's a composer, and he does some of that on the side. He's actually a part of a worship team, worship group, and he's involved in ministry. But as a part of his college training, he came home from college one day and he said, "Dad, I'm taking a coding class." And I said, "Dude, you're like a performing artist. What's up with that?" He said, "Dad, I'm learning how to code so that I can build a web page to promote my career." It's like, yeah, love it. So even performing artists like my son, taking computer science, sprinkling it with their passion, boom, ready, set, go. My daughter Lila, she's a sophomore at Northern Kentucky University. Yeah, my daughters, they love Kentucky, see? And she is studying media informatics. Informatics, here we go. And media informatics is where you combine literature, storytelling, 3D modeling, animation, some aspects of business like public relations and promotion. You have this thing called media informatics with, of course, computer science and coding sprinkled in. And I don't know where that's going to lead her career wise, but she's loving it. I mean, it's absolutely fantastic. Bottom line, my kids are poster children for combining computer science with your passions. So I say all that to say this, you guys are in a good place. The fact that you're taking a computer science course, yes, combine that with the thing that really yanks your chain, and you've established a really exciting future for yourself. On to slide 2. So our plan for today, this is a content review session. Notice the word review. So there may be some things that we cover and you think to yourself, gee, we did this a few weeks ago. Okay, well, we'll do a quick flyby of some of those things. There'll be some other topics that we'll do a little bit deeper dive. And you may have noticed from Dr. McGuffin's slide, data or primitive types and using objects are the key themes. But we have this thing called strings that is going to kind of bridge the gap between those two. And this whole notion of primitive types, of course, we'll start with that. And then we'll work our way through that, through the progression, and we'll see how it goes. There's a lot of stuff. There are a lot of goodies in this slide deck, and we probably won't get to everything. But I would encourage you, based on the link that I've shared with you, make a copy of this document so that you have access to all the resources that are there. And then you can go back and take a look. You can contact me if you have questions about some of the stuff that you see there. And so you have permission to take this slide deck and make your own copy of that. There'll be some documents along the way, particularly some PDFs, and you want to use, and I give you the link here on slide 2 to Cami. I don't know if you guys have used Cami, but it's a document annotation tool. It's where you can take a PDF and then you can add your own annotations to it. It's not like you're really editing the PDF, you're kind of adding to it, but that's a useful tool, and it'll be useful for some of the exercises that we do. Or if you guys have a printer wherever you're sitting, if you want to print out some of these documents and you write the things down the old-fashioned way, that's fine. However you want to handle that, or whatever tool suits your purposes there. So this is the kind of the big picture of where we're headed. All right, so I'm just going to dive right in, and we're going to do some real quick flyby and some review kind of topics. If for some reason, like Speedy Gonzalez, I'm just going way too fast, stop me, and we can take a look back. We can slow the pace. This is your day. This is your morning, and I want you to get the most out of it. So feel free. Don't be shy. Advocate for yourself during this session today. Okay, so Java, of course, is our programming language, and we're just going to do a real quick review. We have this thing called a compiler. Essentially, it's a language translator. And the reason we have it is because computers don't speak the language we speak. They only speak ones and zeros. They only speak binary. And we have to have this thing, the compiler, which translates then a language that's convenient for us to the language, the only language that computers understand. And just to remind you that when the compiler is doing its job, it's looking for syntax errors, typos, maybe we could suggest, but not logic or runtime errors. So if we set pi equal to 2.14 and we get the wrong area for a circle, the compiler's not going to catch that. That's completely on us. And as we work our way through some of these exercises, there'll be some coding snippet kind of things that will be a part of our activities. Whatever coding environment, and you'll see some links to some of these here a little bit later, but whatever coding environment you're comfortable with, it might be Replit, it might be Rex Tester, could be JDoodle, maybe you have NetBeans installed on your computer, I don't know. But feel free to use whatever coding environment suits you. So when we are writing our programs, we could say Java fits into these broad, very broad categories in order to make sense of the code that we're giving to it. And keep in mind, comments are things that are not, are essentially ignored by the compiler. And so for today, we're going to talk about identifiers, reserved words, literals or come up operators, and of course, punctuation. Java is a language that includes punctuation. There are some languages like Python, no punctuation. And that really is over the course of time, as you learn more programming languages, that's just kind of a personal preference. Not that programming languages with punctuation are better or worse than others. It's just kind of the way they are. So comments, there are different kinds of comments, and you may see different versions of these as we go along. There is I don't know if you guys have covered this in your class, but you can use the slash double asterisk, and you have this Java doc thing that kicks in. And oftentimes it's used in industry in order to take established code and immediately go to the tech documents that maybe get pushed out to users, or maybe get pushed out to those that are maybe distributing the software. So that's kind of a cool feature that's built into Java. By the way, you're going to notice on these links that I pushed out here, the word Oracle repeated. Now, why? Why would I use that as a prefix for the various Java links that I'm giving to you? Anybody have any idea? And no, it doesn't have to do with Greek mythology. Well, it kind of does, but anybody know, ever heard that word oracle? You can just bring up your mic and just answer if you know.
Rob, you can go ahead and open up your mic if you want to make your statement there.
Oh yeah, sure. Does somebody have an idea?
Does Oracle purchase Sun back in 2010?
Yeah, they did. And so what does Oracle own then?
Oracle owns all of Java because they purchased Sun. They
Yep,
also own Spark processors and everything that Sun had.
Yep, boy, you're taking me back a trip down memory lane, because before I came to teaching, Sun, I mean, we worked on Sun workstations. I mean, that was it, and Spark and all that. But Oracle is the company. Not only do they own Sun and Sun products, those are that's a brand of computers. Those of you that aren't familiar, but Oracle also owns Java, the programming language. They're the keeper of it, the developer of it. And so when you go, and that's kind of important when you're thinking about Java, and you really don't want to know what the framework under which Java is operating, go directly to the source. I mean, you could find maybe uh, some good non-Oracle sources like Stack Overflow. I mean, you go to some places like that can be helpful. But if you want the definitive source, so here you go, guys. If you want the definitive source, go to Oracle. So that's why I'm repeating this throughout, just to remind you of that, who has developed and who owns then Java. And so we have this thing called Java Doc. It's not really part of what the College Board expects you to understand as far as being assessed, but you're going to see, you might see that in some code. And I just wanted to make that clear to you. We have this idea about literals. Those are just actual values that appear in our code. And I've given you a link to Java literals. You could take a look at that and see. You can have numeric literals, string literals. How about these two? Hello and then F. Why am I distinguishing those as two different types of literals there? What do we have going on?
One's a string, one's a character.
Yeah, one's a string and one's a character. And what you need to keep in mind that a string is a collection of characters. And then we have this single character. We actually have a data type that's just for a single character. And Java thinks about that very differently. And there's just some interesting relationships between character data and integer numeric data, some kind of interesting things that we can do as it relates to those two data types. We have keywords. That's really important for you to know the various keywords. That is part of the vocabulary of Java, and I've given you the link there as well. So this is just a reminder about who owns Java. Identifiers, here are the rules, and you guys have probably gone through all of this whole list. Really what it comes down to is that you can use letters, numbers, underscores, and dollar signs in your identifier, the identifiers that you use. And I'm using the word identifier because identifier is a name that we can apply to a variable, which is just a chunk of memory that we're using from the computer. But identifiers also come into play when we're naming classes and we're naming methods, and the list goes on and on. And you're going to hear me echo this throughout our day today. Make sure you use descriptive identifier names, and make sure you're using camel notation, or sometimes called camel case. Now look, guys, this is not, and your teacher has probably emphasized this to you as well. This is something that Java does not enforce. Java doesn't, when the Java compiler runs, it doesn't say to itself, I wonder if that identifier name is descriptive enough, or if they're using camel notation. It doesn't do that. I mean, you could fashion whatever identifier names that you want. But here we go. The coding convention that is established at the university level and also out in industry would say this: make your identifiers descriptive and use camel notation. So by making it descriptive, you might have multiple words in that identifier name. Well, if you have multiple words for a variable, the first letter of the first word is lowercase, and then subsequent first letter, beginning letters of words in your identifier name are uppercase, like humps on a camel. And the expectation is, just telling you, when you get to the university level and when you go to establish your career, that you have that locked in. That's a part of your coding DNA. Yeah, so just make sure. And again, it's not anything that, if you go to Oracle Java identifier and take a look at some of the examples there, or the rules or the guidelines, it wouldn't say anything explicitly about that. That's what we consider coding convention. So when we're writing our programs, this is just an example you'll see on these two slides of some variable names that are acceptable and some that are not. The ones that I've crossed out, yeah, well, why? Somebody want to speak to the ones that are crossed out? How do those violate? In what way do they violate Java identifier guidelines? These are easy kind of questions. I'm just making sure you guys are awake. Anybody have an answer?
They're not very descriptive.
Okay, so you're going right to the coding convention side of things. Okay, thank you for that. Okay, we want to think about being descriptive and camel notation. What about and of course, Java doesn't care about that so much. So, but thank you for reminding about that. I appreciate that. How about from the Java side? Because you're going to get a compiler error on the ones that are crossed out.
$12 starts with a number. My dog has a space, and public's a keyword.
Yep, brilliant. You cannot start with a number on an identifier name. Public's a keyword, and my dog has a space. Okay, good. So yeah, keep that in mind as you are establishing your identifiers, variable names, and so on. Java is punctuation sensitive. Think about semicolons and think about your blocks. Now, we're not talking about control structures today. I think that's a topic for next month, but let me just give you a little heads up. I think maybe I'm a part of that session, but I'm going to really, when we talk about control structures, I'm going to really hammer this whole notion of a block. And when you have a loop and when you have an if statement, block all of your statements. Even if it's just a single statement. I know the compiler doesn't require it if it's a single statement. I'm just telling you, this is another coding convention thing. You're going to save yourself a lot of heartache and grief by blocking all of your if statements, blocking all of your loops, regardless, even if it's just a single statement associated with it. There's just a heads up. You see the Oracle Java order of operations. Important for you to have that in mind. Now, some of the operators, the arithmetic ones that are listed here, you guys probably have that down cold because you've seen that whole PEMDAS, GEMDAS thing. You've been doing that since like 3rd grade or whatever. I don't know. But there are probably some other operators that are new to you, particularly the relational operators, the Boolean operators. And it's important that you have an understanding about the progression. How are those operators, how is Java going to treat those? It makes a big difference in you understanding or actually fashioning the code, understanding how an expression is going to be evaluated by you knowing the order of operations. So there you have the definitive source, Oracle, giving us that, providing us that information. We even have in our classes, we have exercises we'll go through operator scavenger hunt. And then we'll have exercises where students are looking at expressions. And I'm sure you guys have gone through those kinds of exercises as well. Really important for you to have that down cold, the Java order of operations. Java's case sensitive. So we see these 3 variable names, dog, dog, and dog, very different. Not all programming languages are case sensitive. Some are case insensitive. So just know that, and you probably have covered that already. Syntax, again, those are the formal rules. I'm on slide 11. Just those of you should be following along, by the way, in the slide deck, because there'll be some places then where you're going to dive in. You're going to follow some links. So kind of wrap this up with regard to compiler. The syntax, those are the formal rules that allow Java to make sense of what we're commanding the computer to do. It has to have those rules are the guidelines, so that's not chaos, so it can understand what it is that we're trying to do. And it's very interesting, this whole notion of syntax. It's where computer science really overlaps with the topic or the subject area of language. Those of you that will go on and maybe study in greater depth computer science at the college level, what you'll discover is that we have things that are called grammars and lexical analyzers that are built into the realm of computer science that come from the realm of a language. So it's a really cool kind of overlap between those subject areas. By the way, I just happened to think about that. Those of you that are looking maybe for extracurricular organizations that are doing some interesting things with computer science, computational linguistics, North America Computational Linguistics Olympiad. It's sponsored by Carnegie Mellon University, NACLO, NACLO, and they do some really interesting competitions. They're now virtual, and they're getting ready to start their season, where that combine problems that you're solving using computer science and using linguistics. Really cool stuff. Really cool stuff. So check that out if you're looking for maybe extra involvement in the realm of computer science that then tie in other subject areas. So we have different data types, as you know, that we can use. Java is a strongly typed language, very strict in the way that it enforces it. And we're going to talk initially about this thing called primitive data types. Now, are there any of you that are campers? Any campers out there? Anybody?
Yeah.
Yeah, okay. So Ryan, you're a camper. Was that Ryan that spoke?
Yeah, that was me.
Okay. Hey, Ryan, what kind of camping do you do? Have you ever done primitive camping, or describe to us your camping experience?
I've done tent camping, I've done camper camping, I've done RV camping. So all of it.
Oh, the whole spectrum. So tell us, for those of us that don't know about primitive camping, tell us about primitive. What's that all about? What's that look like?
You kind of go in the woods and you go basically with like a backpack of stuff
Mhm.
and you go for a weekend and find your own food, or maybe you bring food, but it all depends on what you're into.
Okay. So when you do primitive camping, the campsite's very different than when you're doing like RV camping, I assume. Is that
Yeah.
right?
Yeah, usually if you're doing primitive camping, you park on a road and then you just walk into the woods and then go wherever you want.
So just you and the trees.
Yes.
I'm just all of a sudden, Ryan, I just got a picture of you hugging the tree. It
Oh,
was it was a thing of beauty.
it was, wasn't it?
But with RV camping, think about that. Now that's the other end of the spectrum. There you have all kinds of amenities. You've got running water, you've got electricity, you've got a beautiful shower room right around the corner, maybe, or in your, if you have a big enough RV, your shower room right there in your vehicle.
Yeah.
And so this whole notion of primitive, and we have that. We have those different types of camping that live inside the realm of Java. We have primitive camping, we have primitive data types where there are no amenities. All you have is a chunk of memory and something stored there, very simply. But we also have at the other end of the spectrum these things that are called objects that are very complex, a lot of amenities, a lot of features. Running water, electricity, all that kind of stuff, very complex. And those two things, they seem, why would these two things be living in this one language? But some of it is a legacy issue because Java, if you check Java's ancestry, it goes back to a programming language called C that had this whole notion of these primitive data types. So it's kind of a legacy issue, and it's in some circles a point of controversy. Some suggest that Java is really not fully a or object-oriented programming language because it's contaminated by these primitives. Okay, so wherever you are with that regard to that controversy, we have these things that are called primitives, primitive data types. And we can declare then variables of these types and then very simply just assign values to them. But we're also going to talk about strings. Strings are interesting creatures, and you guys have probably covered those in your class. So we're just going to take a real quick flyby. We have this thing called double, where we can store floating point numbers. And then we have basic arithmetic operations that we can perform then on numeric kind of data. And you see the link there out to Oracle Java for that. We have other situations. Now you got to remember, and you guys know, Java is very, very restrictive. It's very strict in the way that it deals with data types. It's a strongly typed language is what we would say. There might be times where we want to store information without a decimal portion because double, as you guys know, will allow us to store floating point numbers. And sometimes maybe we want to go with just whole numbers, maybe for efficiency's sake. I'm now on slide 16. Maybe could be aspects of accuracy. Maybe we just don't need the fractional part. And on these next three slides, 1.7 pennies doesn't make sense. 2.3 children, that doesn't make sense. Half a brain, okay, doesn't make sense. There are just situations where we need we're just considering whole things. And that's why we have this data type that's numeric, like double and float, that allows us to keep track of whole numbers. And then you see that the whole range there that's associated with int and with long. Now, how can we, well, maybe I'll just, yeah, so let's toss it out this way. Notice that for int, plus or minus, we're allowed that range, roughly that range, negative through these positive numbers. Now, what if we wanted to, for an int, Let's say we just wanted positive whole numbers. There is a way in Java to get even more storage if we're just dealing with positive numbers. Anybody know what that keyword is that we can use with int and with long in order to free up a little bit more storage? Go ahead, Chair.
Signed versus unsigned.
Yep, that's right. You have signed versus unsigned. So you can use unsigned as a keyword. So if for some reason you want to free up another bit, then you can do that. You can almost think of it this way, that sign plus or minus is occupies a bit, even though the way it stores the numbers uses what's called 2's complement. In practical sense, it's just another bit that would become available. And so then you get another power of 2 that's available for those to store whole numbers. Okay, so you have unsigned. And then here are just a few examples. Some of the first three are kind of like duh. On the or should be obvious to you about how we arrive at that. How about the fourth one down, 11 divided by 2? Why did we get 5?
Because integer divide by integer, it give us integer.
It does. We have integer division that's happening. And you got to pay
Yes.
attention to that. When you are fashioning, thank you for sharing that. When you are fashioning your expressions, you need to think about what are my operands? Those two things that are on either side of the operator, because these operators that we're seeing here are binary operators. There are some other operators that are unary. We'll look at some unary ones, or I'll remind you of those. And when you have two integers, you're in Java, and you divide, you're going to get the whole number result. Now, it's not the case for every coding language. JavaScript's not that way, and others are not. But it is the case for Java. How about the fifth one down? 11, then we have this percent sign in 3. First of all, what's the percent sign? What operation are we performing there?
Modulus.
Modulus. And why is that 2?
It gives the remainder.
It gives the remainder. So 3 goes into 11. It goes into 11 3 times, and then we have 2 left over. Okay, good. So we have modulus. That's fair game. The College Board expects you to know that, understand that. And then, of course, we have the runtime example divided by 0. Java, that's just there to remind you that JavaScript or Java. Every once in a while, I'll say JavaScript. That'll be a Freudian slip, because for my computer science principles class, we use JavaScript. So anytime during the session today, if I make that Freudian slip, just substitute Java for JavaScript. Okay, thank you. So 9 divided by 0, Java is paying attention to the foundations of math. That's just there to remind us of that. Now we get to our good friend string. Yeah, string. Kind of cool, because a string is this, in some respects, bridges the gap between primitive and then an object, between primitive camping and RV camping kind of thing. It's kind of in between, where you're taking a tent, and maybe you have some running water, or maybe you don't, or maybe you have a bathroom around the corner, or maybe not. It's kind of in between there. And we'll often use then, as was suggested earlier, someone mentioned, if we have a collection of characters of information that we want to store, then we're going to use something called string. So we have the string class, and I've given you a link to that. And again, comes to us from Oracle, and you get the complete listing of that class, including all the methods that are available. Now, you might want to open up this tab, have this available, because we're going to do an exercise in just a few minutes that involves strings, and you want to be able to look at the string toolbox given to us by Oracle. So that's going to be a useful resource for you. Okay. What are some of the things that you'll see there? Length, character at, substring, and I've given you a link to the Java quick reference. Hopefully you guys have seen this document. I'm now on slide 23. Hopefully you've seen this document, and this is, in case this is brand new to you, this is the document that the College Board will give to you when you sit for the Computer Science A exam in spring. This would be by your side. So for that reason, here we go. Dear students, now hear me on this. Make sure you do this in the proper way. You should be seeing this quick reference each and every time you do anything assessment-wise, multiple choice, free response. This document should be by your side. It's a pop quiz, it's a unit test, a semester exam. This thing should be by your side. It's kind of like your constitutional right as a computer science A student. So hopefully your teacher is making this available and following the recommended, the suggestion of the College Board. If your teacher is not, now be courteous about this, but just go to your teacher and say, teacher dear, I'm assuming that's how you address your teacher. Teacher dear, that old man from Cincinnati said that the quick reference is our constitutional right. Would you please make sure that this document is available to us each and every time we take an assessment? You know, very courteous. Don't go bursting into the room, you know, like some crazy person. But deal with that, assert yourself, but do it in a courteous way. You need to make sure that you are regularly utilizing this, becoming comfortable with the subset, because if you look at the set of string methods, it's much less than what you see out on Oracle. Get familiar with the subset of methods that the College Board expects you to utilize on their assessment. Get comfortable using those, and this document that's going to benefit you going forward from an assessment perspective. It's really going to help prepare you then for what the College Board has in the spring. A few other of the string methods that are available, some that could be used for comparison as well. Equals and compared to, as you guys know, strings they're a different creature. They're not like primitives where we can use the arithmetic operators. Well, we can on strings. And well, okay, so let's just address that. What happens? A string is an object. Okay, let's just deal with that elephant that's in the room. It's an object. All right, and if we use then the arithmetic operator for equality. By the way, somebody share with the group what is the not arithmetic, the relational operator, misspoke. The relational operator to check for equality for primitives. What do we typically use when we're checking for equality?
Equals.
Yeah, double equals. What happens, pray tell? Sorry to get Shakespearean on you. What happens, pray tell, if we use that relational operator when we compare two strings? What are we asking Java?
Use equal to method.
I'm sorry, say that again.
And with a string, we cannot use the equal sign with the string. If you want to compare between two strings, we're supposed to use a string equal to method.
Well, you can. Okay, so let's address that. You could take two string objects and you can use the equal to do a comparison. Java will let you do that. But what are you asking Java to do when you use that relational operator with two strings?
Memory location.
Memory location, exactly. Memory location.
They will compare the identity.
Yeah, you're comparing the memory address that's been given to that string object. You could think of it like an address that's on the outside of a mailbox, right? You're not asking about the contents in the mailbox. You're asking about the number that's on the outside of the mailbox. Is that number the same when you use the equals and that goes for really any object, and of course that would work for strings as well. And that's why we have this method called equals. So we could say whatever the string object name is, dot equals. Then when we use dot equals, we are saying, please open up the mailbox, look at the contents in the mailbox, and tell me if the contents are the same. So because a string is an object, it's much more complex. There's a lot of stuff bundled with the string object. And so there are times maybe we want to know what is the address, what's the number on the outside of the mailbox. And there might be times where we want to ask, please open up the mailbox and compare the contents and tell me if they're the same. Okay, so that generally applies to all objects that we might encounter. On slide 24, there's a link at the bottom that says strings review. And we're not going to take a thorough look at this, but I just want to point this out to you. Are there any of you that are using CS Awesome?
Yeah, me sometimes.
Sometimes, okay. Anybody else? CS Awesome? Renee, I think you guys are using that, right? Are your students?
Yeah, so there's probably like 4 or 5 people here that are using CS Awesome.
Okay. So it might be split. Maybe half of you are using it and half of you aren't. Some of these links that you see here are going to push you out to CS Awesome or even some legacy links, some older links that have been around that are associated with CS Awesome. CS Awesome is an online curriculum that's designed for Computer Science A. And there's some really cool lessons that are out here dealing with the whole spectrum of topics that are a part of Computer Science A. And so I've given you a link to this overview of a string and this whole notion. Here we go. And this really goes to what the discussion we just had about equals. This whole notion that when we have a string, when we construct a string, it's an object that then has a reference, has a memory, an address associated with it. And then we have the contents of that. And it's going to reference then a particular class. It's called a string class that has all these various members that are in the class. Very complex creature, even though at times it appears to behave like a primitive. And this really makes the point, this little diagram that you're seeing here makes the point that in order for us to compare the contents, the attributes that are given to us by the string class, we have to use this the equals method in order to essentially open up the mailbox. That's kind of an interesting diagram that's given to us by CS Awesome. Oh yeah, I got to deal with ads. Okay, fine, whatever. Close. There we go. And then we talked about this just a few minutes ago, that a string is a collection of characters that's zero based. Hopefully you guys are good with that whole notion of zero based. Well, here's what helps me when I think about this, because we encounter this with arrays as well. This whole zero based notion. Some programming languages are zero based in the way they deal with strings and the way they deal with arrays. Because Java, its DNA is rooted in the programming language C that's been around for a long time. It then thinks of the index values you see on this example 0 through 13. It thinks of those index values as offsets from the beginning of the array. So when you're thinking about the indexing as it relates to strings and arrays, maybe substitute the word offset or think about the word offset. And maybe that'll help you in your understanding about why is it zero based. Because to get to the T that's in that string, how far offset from the beginning of the array do we need to be? Well, we don't need to be offset at all, 0. We're at the beginning of that string. So T is offset by 0. H is offset by 1 from the beginning and so on. So that's the backdrop of why it's zero based and why strings and arrays are zero based. And then you see in this CS Awesome a lesson, you'll see then some examples that'll go through here and that'll let you run some code. This is really cool about that. One thing I really like about CS Awesome is you have built into these lessons, these coding sandboxes. And who doesn't like to play in the sandbox? I mean, really, who doesn't love to go to the beach and just play in the sand? And you have that built in to the lesson that's right here. And you can make changes to this code and you can run it. And some really cool features. You got actually have, there's a active code where you could do get a sense for almost like from a debugging standpoint, how the code is progressing. Really cool. That's built in to CS Awesome. And then you have these check for understanding. So I would encourage you, if it's been maybe a while in your class since you've talked about strings and maybe you're focused on some other topics, go back and work your way through some of these exercises. Just make sure that you're good to go on your string, the string concepts. And you could do a check me, you could do a compare me, and work your way through some of these activities. Okay. And then we get into this whole string equality. You see the double equals, the question about that we discussed, and some diagrams related to that. And it just goes on from there. So that's going to be a really good resource for you, maybe to reinforce some of what you thought you understood, or maybe understand about strings. A really good way to review then. And have that ready as we're working through some exercises here. Might be useful to you. Okay, so here we go, slide 25. Without peeking, because slide 26 is going to reveal. Okay, so on this very first one, we have HIPSH, and that's our string. What can we say about length? So what are we going to get from length on that one? Somebody just speak that out.
5.
5, thank you, good. How about the next string? We have zoology and character at, char at.
Z.
We get the Z, remember 0 based. How about character at 4? What do we get for that one?
Because there's no index 4.
Yeah. Yeah, good. And I heard several of you chime in on that. Good. We've gone off the end of the string because it's 0 based. The Z is at index 0. It's offset by nothing. It's at the beginning of the string. And then the O, 1, 2, 3. So 0 through 3. And we're saying go to index 4, and Java's going to say, sorry, dude, can't help you. No, can't do it. How about substring? 0, 3. What do we get?
Okay, PIC.
We get PIC. Yep. Yeah. So keep in mind that in the case of substring, the second number that we give it is 1 beyond. Yeah, it's 1 beyond the index position that we want. How about index of A?
0.
We get 0. What happens if we do the compare to? Cat, dog.
-1.
Yep, we get negative. Now, compare to is an interesting method, and you guys can look at the details of that, but generally it uses the Unicode set of tables, and more particularly the ASCII table. This is where we get into the really interesting relationship between characters and numbers. And it really goes to this whole notion of computers only speak numbers. In fact, they only speak binary. In fact, everything that we represent in our code, data and otherwise, has to be in the form of a number. And that includes our strings. That includes the characters that are in our strings. So we have to have these tables that then serve as a lookup tables that can convert to characters that are convenient to us, and numbers, the only thing computers understand. And so for the compare to, it's using that table lookup. It's going to the table and just going one character time, and it's saying C, and it's comparing it to D. And it's saying, is in the table, does C have a lower number? Does it come first, capital C, before uppercase D? Well, it does. So it means it's less than. So then we get a -1 in that case. And then it stops. It doesn't need to look at A and T compared to O and G. It can stop after looking at that very first character. It knows that cat is less than dog, and we get a -1. How about cat compared to cat?
1.
Nope.
0.
Yeah.
We get 0. Right, we get 0. Right, so if the two are the same, then we get 0. And then the last one, cat, no, go ahead. I think somebody answered on this one already. Cat compared to kitten. Or cat equals kitten now. Sorry, not compared to. Cat equals kitten. So we're switching the method there. We're not using compared to now.
-1.
No, now we're using, that's what we're using equals there.
Oh,
Not compared to.
false.
Yeah, we get false. Right, so cat equals kitten, false. What if we did cat compared to kitten? What do we get?
Negative, because they're in alphabetical order
They
or
are.
lexicographical order.
Right. C comes before K. Okay, what if we had kitten compared to cat? What would
Or,
Java? We get what?
or the opposite.
We get the opposite, or we get 1. We would get 1. Right, because K, if we flip those two and said compared to, the K is greater than the C, and it can stop after that first character. And so kitten is greater than cat if we're using compared to. Okay, good. Yeah, and you'll see that on slide 26, those of you that cheated and looked ahead, okay, whatever. It's not like I'm going to report you to the principal or anything, but you can see the answers that we have here. Okay. Some of you are probably maybe have already discovered Coding Bat for strings. Really good resource for honing your strings skills. And look, guys, by you really going after this whole string business, it's going to really strengthen your ability to process arrays. I'm telling you, it will. And we really hammer our students hard with strings, because what we've discovered down through the years is if our students have strings down cold, the ability to manipulate them, process, then their array skills are so much better, and their objects skills generally are so much better as well. Okay, so Coding Bat can help you with that as well. Consider that. Is Dr. McGuffin still in the room? I just want to make sure. I think we're supposed to hit some kind of break, and I want to make sure that we're not missing that particular break time.
Yeah, we are ready to take a break. So let's see.
Is now a good time, probably?
Yes.
Okay. When we return, just to give you a little peek, we're going to do a couple of exercises related to strings, and we're going to do some breakout groups, and then we're going to look at a free response question, and then we're going to go on and talk a little bit more about objects. So there you go. Dr. McGuffin, if you give us instructions about the break.
Sure
please.
will. It is 10:58. So let's take a short break and come back at, let's look at 11:05.
Okay, sounds good.
11:05. All right.
Thank
So
you.
we'll see you back at 11:05.
I want to go back and do just one clarification before we go into our breakout activities related to string. I want to make it very clear about the compared to method that we were discussing. Let's be clear about compared to. I explicitly said -1 and 1. Really more correctly stated, either less than 0 or greater than 0 is really what we have to with compared to. If like on this slide 25, where cat and dog, you really need to set up your comparisons, your relational operator. You should be using inequalities in order to check to see whether a string is One is greater than or less than another. So either less than 0 or greater than 0 really is a better way to state what compared to is going to return to you. Sometimes you might get a -1, you might get a 1, but you might not. But you're definitely going to get, if the first string is less than the second, you're going to get a negative value. If the first string is greater than the second, you're going to get a positive value. And if they're equal, then you're going to get 0. That's what compare will give to us. Okay, so I just want to be crystal clear about that. All right. We're going to, there are a couple of breakout activities that we're going to do. There's kind of increasing level of complexity. The first one is fairly simple. It's a string scavenger hunt that we'll do. You guys are going to be pushed out to your breakout groups, and you got a short little coding kind of exercise, which you could use your coding in your groups. You could use some coding environment, some coding sandbox in order to try certain things out, just see what you get. But it's an exploratory, and it's called string scavenger hunt. It's because it's an exploratory into string capability. And you'll see on slide 27, think, pair, share. Now, I don't know if you've ever used this strategy in class, or if you're familiar with it, but students, but it simply means that once you get into your breakout rooms and you have a particular a coding problem that's been assigned to you, spend in your groups, spend a minute or two just without any conversation, you yourself individually looking at that problem and thinking about it just for yourself. So let everybody in the group, give them a minute or two once you settled into your room to just look at it and think about it. Then after you've had that short period of time, then begin to talk amongst yourselves. That's the pair side of it. You could do the pair with more than 2 people, and that's what you might have some breakout rooms where that's the case. Then you share within, then you talk within your breakout room about that. How would we solve this? And then I'll be roaming around and I'll be checking on the different breakout rooms, just seeing how things are progressing. Once it looks like you guys have some idea about a solution and some consensus, then we'll come back to the main room, and that'll be the share portion. We'll just go through and we'll let each breakout room share what they've discovered. Now, I think we have, Dr. McGuffin, we have 4 breakout rooms. Is that right? Is that what we set up?
Yeah, I've got 3 breakout rooms for students, and so there are 3 or 4 students in each breakout room. And then I've got 1 breakout room just for teachers. And so teachers, you can go through the activities, you can have some professional development time just with other teachers and just converse as you wish. So that's the way I set it up. And then Mel will be hopping back and forth through the rooms so that if you have any questions along the way, there should be an option for you to ask a question, and then Mel or I can hop into one of the rooms.
Sounds great. Awesome. So here is our assignment, string scavenger hunt. You're going to use strings to solve problems. The idea is this, that you're giving then some starting string, and then you're given then another output string, and then you're doing a system out print line of that output string at the very end. And then in between is some code that's going to take the input string, and using the string methods is going to be able to generate then, when you do a system out print line, will generate the output that you see in the 3rd column. And there are actually 4, let's see, 1, 2, 3, 4 different coding problems for you to consider. Okay, so here's what we'll do. Are the breakout rooms numbered or lettered, Dr. McGuffin? How do we?
They're numbered. And so rooms 1, 2, and 3 are the student rooms, and room 4 is the teacher room.
Okay, so here's what we're going to do. Those of you that end up in breakout room 1, take the first coding problem, string of a certain length. Feel free, you see in the instructions, feel free to use Replit, Rex Tester. I even give you the links to that if you need JDoodle or whatever coding environment to work through this. So room 1, problem 1, room 2, problem 2, room 3, problem 3, and then maybe when we come back together, or if you have extra time, if you want to consider the 4th one in your group, you could do that. Okay. So we're going to go to our breakout rooms. We're going to spend a little bit of time, just a few minutes, you guys working through that, and we'll see what you have discover about string capability and how you might use that, leverage those capabilities to solve some of the problems that are described here. All right, so breakout rooms, ready, set,
Sounds
go.
good. And just an FYI, I just got a message that I've got some other students that are joining us a little bit late. So if you have a new student that comes in, get them caught up on just what you've been doing, if you don't mind. All right, here you go. Okay, now I just paused the recording and I can put you in whatever room that you want to go to, and then you should be able to hop back and forth. If you can't, for some reason, come back to the main room and then I'll just put you in another room.
Yeah, Sherry, where will I see that when do I need to stop the sharing in order to be able to see that the capabilities to move from room to room?
Let me see. Let me go ahead and
Should I stop
you,
sharing?
you don't have to. Do you see breakout rooms at the bottom?
No, actually my menu bar now is at the top. That's fine. But I don't see breakout rooms. I see participants and I see, stop video, mute, and I see all that stuff. Well, unless it's under more. Oh, it's under more. There we go. Breakout rooms.
There
And
you go.
I'm unassigned, but I can go there and
And you
jump
should be able
around.
to assign yourself. Yeah. If not, then
Got
I
it.
can assign you to one.
Super. Okay. And I just click on the join. That's great. Okay. Thank you.
You're welcome. Welcome back, everybody. We're going to be, we've got about 30 seconds left. We've got some folks finishing up, but they'll be joining us in the next 30 seconds. Hopefully you had some good, productive discussion. All right, Mel, we should have everybody back. So you are on.
Okay, great. In just a second, I'm going to turn it over to each breakout group, let you share about the programming problem that was assigned to you, and just generally describe then your solution. But if you want to share out some code snippets, something you developed related to it, that's fine. I should have, and when I was in one breakout room, I don't know if it was Ryan Current, I'm trying to remember who it was, somebody I was talking with about one of the problems and a potential solution. And they were having a discussion about escape sequences. And immediately my mind flashed back to Tuesday of this week when it went into my mind. I need to put a link out there for escape sequences, and it completely, in the fog of ending the semester and all that, I forgot to put it out there. It's now on slide 27, a link to escape sequences. And those are those special characters that you could put in your strings that control then the formatting of the output. Really important for this, the string scavenger hunt. My bad for not including that link. It's there now. And so there you go. All right, let's go to, I'm going to bring up the string scavenger hunt just to remind us, and breakout group 1. breakout room 1. You guys had string of a certain length. Tell us then, what string methods did you utilize and what was your approach for solving this so that we got this particular output? So breakout room, and you're on. Breakout room 1.
So first, to get the length of a string, you would use string.length with parentheses that would let you know what you're working with. So in this case, 26. And if you wanted any particular part of a string, you could use string.substring. And that from the beginning point of what you wanted to one greater than the end of what you wanted would give you a substring, and then from there you would treat the substring as if it was a new string.
And then you could get its length then and print it as well.
Yeah.
Brilliant, brilliant. How about, and maybe I should have mentioned this when we went into this warning, and I'm just wondering if you guys thought about this. Does your solution work for a string of any 5 words? Is it a generalized solution? Because you mentioned substring, and sometimes when you use substring, you're locked into substrings of a particular length. You'd have to have one that's 6 and one that's 2 and 1. Does your solution generally work? If I gave you 5 words of any length, would it work for any 5 words?
Pretty much, as long as there was something in the string, it would work.
Okay. Without you changing anything except this first line, it'll work then for, in a general way, for any string of 5 words then, huh?
I think so.
Okay, cool. Cool. And that's really the goal in this, is not only to, well, it's one of the objectives. The primary goal is to make sure that you guys are using string methods, becoming comfortable, but also thinking about a generalized approach or solution toward it. Okay. Thank you, group 1, for sharing. Group 2, please tell us about your strategy or approach for solving this one using string methods. Group 2, just bring up your mic and you guys can address it. Anybody from room 2 in the main room, or did you go home?
What we could do is you could use a for loop, and then that would be the length of the string of abracadabra. And then inside of an if statement that checks if the character, well, you could do I modulo 2 is not equal to 0. And then that would give you each character that needs to be changed. And then at that index, use .2 upper and make the characters that need to be uppercase.
Brilliant. I love that, the way you're using, but by the way, maybe it goes without saying, hopefully you guys have already encountered loops and the various control structures. That was fair game to arrive at your solution, but brilliant, using modulus and then using the upper and lower case in order to come up with a generalized solution. Yeah. And would you say then that solution generally works for any string of any length?
It would, as long as for the for loop, it would be I is less than length of string.
Got it. Brilliant. And of course you would want to, that's a great point that you made. You would want to set up your, and we'll talk about control structures, I think next month, but you want to make sure you don't have any off by ones or bounds issues with regard to the string. You want to make sure that you properly construct your loop. Thank you, room 2. That's brilliant. Well, nicely done. How about room 3? Please tell us about your approach using string methods to solve this one.
Okay, so we also use substrings, and like that was all that we needed was substrings, because all these letters are in order in our string. But we didn't make it so that you could, use it with different sets. But if you wanted to, say you wanted to get certain words out of, a string that's given to you, If you knew what words you wanted, what you could do is use a for loop and go through each letter. And then when you get to a letter that you want, so say I wanted to spell out the word set, I could check with a for loop, the first one would be S. So I could use that set and I could use that character, and then build a string of those characters with any string if you wanted. But we didn't do it that way because we didn't know it was supposed to be, able to run with multiple different strings.
A generalized solution, yeah. So you're saying your solution might have trouble with other strings then, might?
Yeah, because we just used a substring like method for each one of these.
Yeah, and maybe you do have a generalized solution, because think about what's really happening here. And sometimes students are fooled when they see the output on this, because they forget that space, or kind of escapes them, that the space is also a character. So on the very first line, we actually have 4 characters there, SET and then a space. So we're really just taking that string and breaking it up in chunks of 4. It really is as simple as you have described, but it's reminding students that spaces that you can break, unlike the very first one where you're splitting it across, you're splitting at the spaces. This one's different. You're just breaking it up into chunks of 4. So a little bit different approach. Okay. How about this fourth one? I know you guys, it wasn't assigned to you, but what do you have some ideas about what's going on there? Maybe how you would solve that one? Well, I'll just tell you briefly on the output, because the numbers, it might be a little bit confusing to you. It's just printing. The numbers are the first occurrence and last occurrence of a particular letter in a string, right? And so then you're just doing index of, right? You're using those capabilities of string and going character by character, and then just considering that. And so you can see by this this particular assignment that it's an exploratory. It's a way of forcing you. Maybe you haven't been forced. Maybe you're not forced to do anything at school these days. I have no idea. But it's forcing you to dig into the string toolbox. Let's go to the string toolbox and see what's there, and let's just try a few things out. And that's why we call that a scavenger hunt. It's you exploring in that kind of scavenger sort of way. We do have, I want to have some time to be able to look at a free response and then do a wrap up related to objects. There's another breakout group activity that if we had a little bit more time, we would dive into it, but I'm just going to show it to you. And teachers, feel free to use these with your students, maybe as a review, or maybe you're going back and revisiting certain string concepts as it's kind of scaffolding toward arrays and some other higher level concepts. But you'll see on slide 27, for all of you, teachers and students, you'll see these larger, I guess, escalated set of problems that then take the string scavenger hunt and take it to another level. AKC Super Bowl, military service, you've got mail. They're all similar kind of in the way that they're approaching it. And they're taking input. I'll just open up the AKC Super Bowl one. It takes then this whole notion of using strings and string capability in order to solve problems. And it's trying to add a real world or realistic veneer about it. So you have this, in this particular one, the American Kennel Club, you're designed to do some work, and the customer data is in the database in this format, and you have to format it this way. And again, you're using then the various string capabilities and exploring it and kind of pulling it all together string wise in a way that you might expect to encounter in a real world setting. And students, as you're looking at some larger problems like these, it really sets you up for certain scenarios that you might see from the College Board. And it's important, and we kind of saw that in the string scavenger hunt to a certain degree. It's important that you test your solution for a variety of different inputs. That's key in all of this. And you see that echoed throughout some of these assignments. You also see this whole notion of make sure there's only one print statement. Look, let's just talk about the elephant in the room related to that. If you become so reliant, there are two things, two cautions that I give you regarding this. If you become so reliant on system out print line or SOP, as Renee, as you and your students endearingly refer to it, if you rely on too many print statements for your solution, then what you'll discover is that you're not exploring enough of the Java capabilities. And that's why on the string scavenger hunt, we said only one print statement. That forced you not only to explore things about strings, but also explore escape sequences. And you'll see the same thing echoed here as well. So for all of you, teachers and students, you have then the kind of the next level of string type. It's sort of a mini project. We call these bridge projects because they really bridge coding calisthenic kind of work that you would maybe expect in the string scavenger hunt to moving you in the direction to the strength of maybe like a free response question. It's kind of intermediate, kind of bridges the gap between those two kinds of activities. So look at those and look, guys, now we're CS pals, all of us, and contact me. If you're looking at some of these and you're wondering, like, how do I approach this, or what's a good way to test it, and you're just baffled by a certain aspect of it, well, let's have a conversation. Let's talk about it, okay? We're going to come back around, or you may have the opportunity to use some of the string stuff in a few minutes when we look at a free response question. I'm going to move on in our slide deck. Types and variables, okay? Remember that you need to think about the data that's going to be assigned to the variable when you think about the data type, but that's also going to affect then the descriptive name that you give to it and the camel notation. And of course, we have now explored some of these simple data types. I don't know if you guys have La Rosa's pizza in your area, but if you have something that's a mixture of kinds of data, typically we would store that in the string. Okay, fine. There is from CS Awesome this variable review and some really good resources there for you to consider. Take a look at that and go through those exercises, including, now here's some really cool stuff. I don't know if you guys have seen this. I think it's on the second. So if I go to the first page and I click on the arrow and go to the second page of this lesson, and you'll see this sprinkled throughout CS Awesome, and maybe you'll see it in other curricula that's out here. But we have this thing called Parsons problems, where you are taking then, they call it mixed up code problems, but you're taking code and you're dropping the blocks to the right-hand side in the proper order, and then you're checking it. So those are kind of cool. Maybe you've not seen these Parsons problems kind of activities. Look at some of those. If you haven't had a chance in your class to see some of those kind of things, and you'll see those sprinkled all throughout the CS Awesome curriculum across all the myriad of topics that are out there. Slide 30, just keep rolling right along. Oh, we talked about that one, yeah. All right, so declaring variables, right? And you can assign it a value, but you don't have to. Shortcut for that. You can assign an expression to a variable. Hopefully you guys are getting plenty of practice evaluating expressions, thinking about the order of operations, really important. We've got to think about differently than we would in the math realm. On the left-hand side, we just have one thing. On the right-hand side, we could have something more complex using what's called the assignment operator. Single equals versus double equals. Sometimes students early on get tripped up by that. And then we have, and of course, it's not commutative either. We don't have that property that's coming into play that we have in the math realm. We don't have implicit operators. That's not a thing in Java. And just a reminder about the different arithmetic operators that are available, including some unary. We're going to see just a real quick flash of some of those operators, unary and compound assignment operators. The College Board expects you to have an understanding about things like this. This is a unary operator, only one operand, right? It's not binary. You don't have to have two operands, just one. Same, we have that, okay? And then compound assignment, like plus equals, minus equals, modulus equals, you know, the list goes on and on. Make sure that you're comfortable with those special kinds of shortcuts or operators. Now to the strong data type checking. We can't assign this string Bob smells funny to an int. Strongly typed language, not allowed. Not allowed, you guys know. We also have the whole notion of conversions. Why is this allowed? On slide 43. Somebody speak to this. Why are we allowed? We've got a 25, which is really an int. It's a whole number, and we're assigning it to a double, which has a decimal portion. Why does Java allow for this?
It's actually giving it more memory space, so it's not a problem.
Yep. We're going to something that is more, a wider type, a greater type. And a visual of that looks like this. You almost have to think about subsets and supersets. We have integers that live inside of real numbers. And if you're going the direction of out from integers out to real numbers, you can do that kind of thing in Java, and it'll automatically do the conversion for us, like on this one. Okay, that is allowed. But of course, if we go the other direction, so now we're going from the outer bubble, real numbers in, and Java will say, nah, baby, nah, can't do it. Because there's some detail that might be lost, and Java is a strict, very strict language. Here we've got a decimal portion with an int. We don't have a place to store decimals. It's a very different internal structure of an int versus a floating point, and not allowed. We'll actually get a compiler error on that. Now, and this also comes into play with expressions on the right-hand side. Keep in mind, when you have mixed expressions, that means that you have a mixture of maybe floating point and decimal mixed with whole number. It's always going to promote. Promote means go to the outside, the larger data type. It's always going to promote. So this thing is going to end up being then a double result in a double value. And then we're going to assign it to an int, and we're going to get the same problem we had on the previous slide, where we have a narrowing conversion. Narrowing is not allowed. Implicitly, it's not allowed. Okay. Now we can force the issue. Hopefully you guys have discussed this in the realm of primitives. We can force the issue by using what's called casting. So on this particular one, we could say to Java, okay, look, dude, I understand. You're going to be upset if I assign 25.9 to an int, but dude, I really want to do that. And the whole number portion gets assigned, and then we lose then the 0.9. That precision, that detail is then lost. Now, this is fairly easy to see, simple to understand, but it becomes a little bit more tricky when we do this kind of thing. And well, okay, so somebody tell me what happens here on this one. What does Java do with something like this?
Casting.
Yeah, it's going to cast. What gets cast, and what happens in what order as far as the casting is concerned?
I think first we'll do the casting, then we'll multiply it by 100.
Yes.
So it will
correct.
It will equal 200.
Yeah. So what happens is then the cast happened first. It binds very closely with the number that's right next to it. Right. So it's going to do that casting and then do the multiply on that. So go ahead.
If we add the parentheses after the end casting, if we make it 2.563, multiply 100 between the parentheses. So
yes.
Multiplication first, then we will do the casting, correct?
Yes, correct. Very astute. Brilliant. Thank you so much for that. So we have in this case, if we don't use parentheses, the cast is going to immediately connect, be glued to the 2.563. It's going to cast that, which means the decimal portion is dropped. We end up with 2. We're going to multiply it times 100. We get 200. Okay. However, as was correctly stated, if we use parentheses to force, remember, parentheses or grouping is at the top of the heap as far as order of operations. It's going to do the multiplication first, and then we're going to get a very different answer on that one. We're going to get 256. It's going to multiply first, then it's going to drop, they're going to truncate the decimal portion and give us a very different answer. So you got to be careful and understand what you're doing with casting and make sure that you do it in the proper way. There are a set of math. Hopefully you guys are getting comfortable with the math library and the set of methods that are there. We can even encounter issues with something like this. You might think to yourself, I'm gonna round this number and then just try to directly assign it. Well, if that casting of int is not there, Java's going to complain. You're going to think like, what? Isn't math round going to make it a whole number? Yeah, but it's a whole number that's a long, not an int. And Java is that picky. It doesn't care if you have two data types that deal with whole numbers. If they're not the exact same data type, it's going to complain about it. So you could take that long and force it to an int. You might lose some precision. Let's say if it's a long number that can be contained in a long, and then you're forcing it down to an int, and you could lose something there with that. But you would need to force it using a cast in that case. And then, of course, here are the set of some of the set of math methods that maybe you might want to consider. I give you the link out to the math class. Make sure that you're comfortable with some of the math capabilities. And of course, you could go back to the exam reference and take a look then at some of the capabilities that are there. All right. Here's another, if we had time, another think, pair, share activities, but teachers feel free to use this related to variables. Here's a free response question that I really like because it bundles in primitive, it bundles in some of the order of operations, it potentially pulls in strings and then takes you in the direction of using objects and some of the features there. It's this free response question called self-divisor. Have any of you seen this particular free response question or a version of it? Teacher or student? Just go ahead and speak if you've seen this one.
Yes, I've seen self-divisor. We haven't done this one in class. We did something similar to it, but not this exact one.
Okay, good. So a variety of it. And Renee, you make a great point. This particular free response question, so this is kind of a tip out to the teachers. This free response question is a version of a free response question from AP CSA exam administration years gone by. It's one that's out there in the list of the full set of free response questions, legacy ones, that we've taken and we've morphed it, scaled it down for an earlier unit in our sequence of units that fits nicely with primitives and objects and dealing with order of operations and that kind of thing. Feel free, please, oh, please, go to the set of free response questions. Feel free to take those and modify them and make them your own, customize them. And if you're wondering, where the heck am I going to find all those free response questions from ages gone by, contact me, dear teachers, or students, have your teachers contact me. I can give them a spreadsheet, complete set of free response questions. I mean, you'll just love it. I mean, it's just great. Our good friend Ria, my College Board, my AP friend Ria has put that together and is available. This one is interesting because it allows you then to explore this whole realm of what's called a self-divisor. And a self-divisor, very simply put, is a number that when you peel off each digit essentially is a factor of the number itself or not. Okay, self-divisor kind of thing that we're dealing with. So yes, is that a question? No, I heard a beep. I don't know what the beep meant.
That just meant someone came in the waiting room, so I just didn't listen.
Okay, well, so this one's really interesting because, and I'm just going to briefly talk you through this because are we nearly out of time? Like, oh, where does time go? I mean, we're just having so much fun here with all this stuff. Like, wow. But for self-divisor, just know, students, teachers, and students, there are two different approaches that we saw when this one was. What year was it? Was it 11? I don't even know, man. I mean, I've been reading a long time, but two different approaches. You could take an arithmetic approach where you're using divide and modulus to peel off the digits to figure out if it's self-divisor. You can also take a string approach. Convert this dude to a string and then peel off the digits. Now there's going to be some converting from string to number. You know, you got some of those kind of capabilities. And then you're going to check as you peel off the digits, is it a factor of then the original number? That's part A of this. Is self-divisor. So is self-divisor is called a predicate method. A predicate just a special phrase. All it simply means it returns a Boolean, either true or false. And so you have this predicate method that you're developing the code for. Is it a self-divisor, this number? Okay. Then part B is, it says, okay, given some start point, find the first self-divisor from that starting point. That starting number. Now that starting number could be a self-divisor, but maybe not. You might have to go to the next one or the one after that. So there's some looping that's involved. And here we go, pay attention, dear students. Usually when you have subsequent parts, the intention is for you to use then, and you see it here described, assume that is self-divisor in part A, works as specified, even if you screwed up part A, dear student. Please assume that part A works and now move on to part B. And then how would you, with a functional is self-divisor, how would you code that? Please, dear students, pay attention to that. And here's another tip, students. When it says assume that earlier part works, please, 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 please do not re-implement is self-divisor in part B. We see that all the time. Students will get to part B and they'll take the code that's in part A and they'll copy and paste it down into part B. Don't do that. Oh, down through the years, here's what we see happen in readings. Readings is where your work is scored. Some readings, the chief reader will say, boom, if they re-implement it, they get no credit. I mean, we do immediately, take it to chopping block. So other times, chief readers might say, oh, well, maybe we'll give them credit, but they better have done it right, and there better not be any screw ups as far as how it fits with the rest of the code. So you really, dear students, you're taking a huge risk when you re-implement, when you don't pay attention to this kind of wording. Assume that the first part works. So this is a really good free response to consider because there aren't a whole lot of parts and it's not overly wordy. And it really gives you a good exercise of primitives, of operators, order of operations, even potentially strings, and dealing with the home realm of objects. Okay, 5 minutes. We don't have time to deal with that in breakout groups, but please look at that one. And then again, let me know, either a teacher or student, if you need to know what are those lists, a list of all those free response questions that I can then take my own and customize them, let me know, contact me. Okay, now the last two slides, boy, I mean, we could spend a whole nother couple of hours if we had the time, even on the next two slides. A lot of real good links out here about using objects. Here we go, on slide 54, Greenfoot. Greenfoot is a great coding, a sandbox, I guess you could say. And even if you've got, some other environment that you're using for coding, there are some worthy activities considering out here on Greenfoot. And Greenfoot gives you this coding environment where you have these sprites of sorts. Okay, sprites are just smart images. And you could use it in this coding environment to create some really cool stuff. And by doing so, it allows you then to take objects and dissect them. Now, I promise you, this dissection will not involve any formaldehyde. Don't you hate the smell of formaldehyde? It's awful. But you're able to cut open, dissect objects, and look at the contents of those objects, to where then you can begin the discussion about, okay, what does an object look like on the inside? And you're dealing with instance variables, you're dealing with constructors, and you're dealing with accessors and mutators, modifiers, all those different categories. And you're dealing with the anatomy of classes. And what you'll see in these links here are exercises related to that. And in fact, on slide 55, we'll even see there's a link. The very first link on slide 55 is a lesson out at CS Awesome dealing with class anatomy, dealing with that very whole topic. What do we see? What are the gory details that we see when we cut an object open, when we look at the class that's associated with an object? And it goes into that discussion about, then we have attributes that are represented as instance variables. We have constructor. Those are those things that allow us then to instantiate. Look, guys, you have to be comfortable with these, a whole different set of I words: instance variables, instantiation. Those are some biggie I words that you need to know, that you need to have down, that the College Board will use. Constructors, we've got the whole notion of and it goes into more detail about instance variables. Please, 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 dear students, when you are designing your classes, make sure that your instance variables are all private. Just get in the habit of doing that. From the industry standpoint, it's what's expected. It's also what the College Board expects. Make sure that your instance variables are private, and then you're going to have methods that allow, in a controlled way, access to that information. It helps you to maintain the integrity of the class and objects that are associated with it. You're then going to have accessor methods. If you want somebody to be able to access a particular instance variable, create an accessor method that allows then the availability to that piece of information. Some really good stuff, activities here relating to class anatomy. And again, if we had more time, we would go through that. I've even given you a free response question. We have seconds remaining. I'm sweating. Seconds remaining. Here's a really good, teachers and students as well, where you could take a look at then, and you see this broken out into bullets. The top portion, you have your instance variables. The bottom portion, you have your behaviors that then manifest itself as methods in a class. And then you're told to then define these different parts of the class. This is a really good activity for dissecting and class, dealing with class and object anatomy. And I think, are we out of time? It's noon. Like, wow.
We are at noon.
Here, there are a couple other slides here that make sure you go through those. And here's my contact information and a few other links for you to consider. Done.
Excellent. Thank you so much, Mel. We really appreciate your expertise and you're willing to share with us today. And just to kind of wrap up, I'm going to pull up the last, well, let's see here. Hang on just a second. There's Mel's contact information for those of you that asked about it. So number one, that was the first thing that I wanted to tell you. And secondly, I have just a group of pieces of contact information. So if you want to
do I need to stop sharing?
I got it.
You got it. Okay.
Yeah.
Thank
there
you.
we go. So here's our information at advancedkentucky.com, and follow us on Twitter and Facebook at Advanced Kentucky. I'd actually just put out a tweet, Mel, with your picture in it, as well as some content. So look out for that tweet. You should be tagged in that. And there's my contact information, smcguffin@kstc.com. If you need to know any more about any of our AP study content review sessions that are coming up. Aaron Timmons, who's the content director for math, and there is his information as well. Mel's information again. Any of the recordings, so if you need to go back and look at this and pull up the materials that go along with it, then you can find those at bit.ly/advancedky, and make sure that that is case sensitive. So make sure you include the capital letters that as they are listed there to access the recordings and the handouts. Next session's February 20th. It's on Boolean expressions, if statements, and iterations. Mel will be with us again. So thank you everybody for attending. We
Can I,
appreciate and
I was
yes,
going to
go
say,
ahead.
I was just saying, I was just going to add that one last thing. 'Cause I wasn't sure if I was on duck for February, so that's good. To help us in our conversation leading into those topics, take a look at self-divisor and see how you might use some of those control structures maybe to solve that. That'll really be a nice segue into our discussion then next month. Thank you.
And Renee, you're exactly right. There are reviews every month. So for those of you that asked, if you check out that bit.ly link, then you can check out every one. Go to Math and Computer Science at the top, APCSA, and it tells you the dates and the topics of every one of our content sessions. Thank you so much, and we will see you in February. Bye, everybody.
So I'll just linger if any of you need to chat.
Absolutely.
Looks like maybe everybody's leaving, which is fine. That's cool.